Hey everyone, so today's video would be into further taking our discussions of logics, and now in logic we want to discuss negation of a statement and inclusive and exclusive use of or. First I would be explaining to you what negation of a statement is. So negation of a statement is to deny or contradict a statement. It means that if I have said the opposite of the statement that I said earlier, it means that I have just negated the statement, or I have said something that contradicts the statement. Negation in symbolic nature, or when we want to represent in symbols, is used represented by this or this. So negation of a statement can be called as a process of finding opposite of the statement. Before moving forward, I would like to explain to you few important symbols that we need to know. The first one is belongs to. This symbol is used when we want to say that an element belongs to a set. So when I say that A belongs to a set B, so I would be using element A belongs to a set B. Similarly, if I want to say that A doesn't belong to B, element A doesn't belong to set B, then I would be using this symbol. When I want to say such that in mathematical language, I would be have to use this statement, this symbol or this symbol. And when I would want to represent subset of, when I say that set A is a subset of B, then in mathematical form or in mathematical language I would have to use this. This is actually not a C, this is more like a U but tilted like this. Now to know more about negation, it is best explained with an example. And now here we have an example. Suppose a statement says all rich people are happy, and I want to negate it, meaning I want to contradict this statement. I have to say something that contradicts this statement, meaning it makes this statement false. So I can say it very easily, not all rich people are happy. Now I have said the contradictory statement of this, but what does it mean? If I ask you that you need to prove all rich people are happy, false, I want you to prove this statement that it is false, then how can you do it? Well, it is really simple. We just have to go around and we have to find a rich person who is not happy. When I say that all rich people are happy, then I am assuming, I am taking if I talk in mathematics, then I am taking my domain as all rich people, and I am collectively saying that all the elements in the domain of rich people are happy. But if I am able to find at least one person who is rich and not happy, then I would be able to contradict this statement. I can contradict this statement. I can say that this statement is not false because see, I have found a person who is rich and he is not happy. So in this sense we can also take a hint that this, when we use all, we are saying that we are actually have used an universal quantifier here from our earlier discussion of quantifiers. You must have remembered that when I want to use universal quantifier, then I have to use all. And now I have, since when I have contradicted this statement and I have found a person who is rich and not happy, now the statement, we can say that now there are few people who are rich and they are happy. Earlier I was saying that all people in the domain were happy, but now I have found a person who is rich and he is not happy. So meaning the elements have decreased from our domain. So if I want to say that, now if I want to reword our statement, I would be saying it in a way like there exist some rich people that are happy. So you see there I have used the word there exist, which indicates that I have used an existential quantifier. Now this use of universal to existential quantifier can be verified again. Suppose I have another example. All students of university XYZ have studied real analysis. And now I want to negate this statement. I can simply say not all students of university XYZ has studied real analysis. Now if I want to analyze the negation more, like we did earlier, how did I come to a conclusion that not all students of university XYZ has studied real analysis? I must have gone around and found a person who is a student of university X, Y, and Z, and he has not studied real analysis. Meaning, I have found a person from our specified domain who has not studied real analysis. So here you can see again that in the background we can sense that the universal quantifier would have to be changed into existential quantifier so that we can represent our statement into a mathematical form. So let us see how we can do that. So I have taken the all rich people are happy example. Like I said, the domains that we specified were all rich people. And if I now want to write this statement into a mathematical form, it would be for all x belonging to R, meaning for all people belonging to our domain, specified domain of all rich people are happy. We have just said the statement that we took earlier into a mathematical form. This is how it can be read. Or we can say that for all rich people are happy. Since we have already specified our domain, we don't have to mention it again into our statement. Now if I want to negate this statement P, I just have to use this symbol that I showed you earlier, which is this. When I use the symbol, I have contradicted this statement, and then it can be read at not all rich people are happy. So when I have negated this statement, I must have found a person who is rich and not happy. So our domain the people from the domain must have decreased. All the elements that we are talking about must have decreased, meaning now there are less rich people who are happy. So how can we represent that in mathematical statement? This is how we can represent it. There exist some rich people such that they belong to the domain R and that they are happy, or there exist some rich people that are happy. So you see how universal quantifier turns into an existential quantifier. We have to remember this whenever we are negating a universal quantifier containing statement or an existential quantifier containing statement. I have not taken the existential quantifier example, but it can be sensed that existential quantifier would have to turn into a universal quantifier for this exchange to be true. So we have to remember this for negation. Universal quantifier turns into existential quantifier, and existential quantifier turn into universal quantifier. And a negative inverse, a word that is inverse or reverse or opposite that we have just said, is added into front of the statement. Now to learn about the second topic that I have mentioned, that is inclusive and exclusive OR, we have to go back to logical connectives that we learned about earlier. So first, the logical connective I want to explain about is AND, that we have also seen about AND earlier. And in mathematics is also called conjunction, and it is represented with an inverted V or this type of symbol. So if I have two statements, statement P says today is a pleasant day, and statement Q says I want to go to shopping, then I can join these two statements to form a single statement, a single compound statement. And how can I do that? I just simply have to use either of the symbol in between of that, and I have just made a statement that is combination of these two statements. So this will be read in similar way. Today is a pleasant day and I want to go to shopping. Now looking at or in mathematics is also called disjunction, and it is represented by this either of this symbol. Or in English language actually is used in two senses, inclusive or exclusive or. When we use inclusive or, whenever we whenever we use inclusive or in the statement, we are saying either the first condition or the second condition, or both condition may exist simultaneously. But when I'm using the exclusive or, I am saying that only one of the condition will exist but not both simultaneously. Now this is very theoretical, but if I were to explain to you in a better way, it can be explained with an example. So let us see a few examples now. So first let us see a few examples of inclusive or. The first example says candidate must be graduate or postgraduate. Now let us imagine this with an scenario. Suppose that there is a job opening, and the job opening's requirement is that the candidate that would apply to the position should be an graduate or a postgraduate. So the statement actually may seem that it requires a person that either is graduate or postgraduate, but it is actually not. If a person is postgraduate, then it definitely means that he must have done his graduation as well. So this statement, when we use logical or in this sense, it means that both the conditions or both the possibility can be applied simultaneously. Similarly, if we see the second example, which is this store sells cookies, drinks or fruits. Now there is a possibility that this store only sell cookies, this store only sell drinks, or this store only sell fruits. But there is also a possibility that this store sells all three of these items. So this is how inclusive or is used. Now let us see some examples of exclusive or. This morning, or I will go to school, or I will stay at home. Now if you go to school, then there is not a possibility that you can be at home, because you cannot be present at two places simultaneously. So here we can see that only one of the possibility is applicable, because you just cannot it it will never be a case that you can be at your home and you can be at your school at the same time. And similarly, the second example says he will pass or he will fail an exam. So this is actually just two possible, either two of the possibility will hold, because a person cannot pass or fail in the exam simultaneously. He can either pass or he can either fail in the exam. So this was the explanation of negation and inclusive and exclusive or. And in the next video of mathematics, I would be taking conditional statements. Thank you for watching.